Alrighty, so we were working with systems of equations, which means we have been using the equal sign in our equations. But now we're working with inequalities, which means they're not necessarily equal. Okay, so first of all, you need to make sure you go ahead and write down this table. So we have the first symbol, which is y is less than, okay? Which means that we're going to shade below the line. What type of line are we going to have? Well, we are going to have a dashed line because the line is actually not going to be part of the solution set. And the reason I say solution set is because the solution is not only one, but multiple. So for example, if I say a number less than 9, well, there's a lot of numbers less than 9. So it has multiple solutions. So the solutions would be in the shaded area. Shaded area. Okay. Now the next one is y is less than or equal to. So we're still going to shade below the line, but the line this time is going to be solid. There's no dashed lines, reason being the line actually is part of the solution set. Okay. So the solution for this one is going to be the shaded area in addition to the line. So plus any coordinate point that's on the line will be included. Then we have y is greater than. Now if it's greater than, we're going to shade above the line. But since it's not able to be equal to those solutions, then we have a dashed line. Anything on that dashed line is not part of the solution set. So the solution is only in the shaded area. Okay. And then y is greater than or equal to. Okay, that means that the line can be a part of your solution set. We're still going to shade above because it's greater. The line, however, is going to be solid because it includes those coordinate points on that line in the solution set. So my solution is the shaded area plus the line, any of the coordinate points on that line. So let's see what this looks like. First of all, we're going to have to put it in slope-intercept form even though we don't have an equal sign, okay? We're going to go ahead and leave that inequality symbol there, but pretend for a few minutes that it is an equal sign. So let's start by putting it in slope-intercept form. So right now I have 5x to y is less than 6. So I'm going to subtract that 5x over. And I have negative 2y is less than, I'm going to rearrange, negative 5x plus 6. Okay, well, we're going to have to divide by a negative 2. When you divide by a negative or multiply by a negative on an inequality, you have to flip that sign around. So I have y still here, but my symbol is now going to be greater than. Okay, and so 5 divided by 2, actually negative 5 divided by negative 2 will actually become positive because a negative divided by a negative is a positive. So leave that there. 6 divided by negative 2 is a negative 3. All right, so before we go any further, you might want to make a note. If you multiply or divide by a negative, then you need to make sure you flip the symbol. Okay. Let's go ahead and figure out what the slope is. We have a slope of 5/2. Rise 5, run 2. We have a y-intercept of negative 3. We have a line that's going to be dashed because it's not. So if I plug in a 2, I get 2 is Okay, well, sorry for the long pause. I don't know what happened there. So let's go ahead and start graphing. We're going to start at -3 here. And we're going to rise 5 and run 2. So I'm going to run to the right 2. Again, rise 5 again, run 2 again. And we're going to dash that line like so. And we need to shade above it. Shade above. And all of those in the shaded area, all of those coordinate points are solutions to this singular inequality. Now we're going to go ahead and do our system. All right, so here we are with our system. Again, we still need to put it in slope-intercept form. So I'm going to do the first one, and if I subtract the x over, I have -y is greater than 6 minus x. I need to divide out that negative by dividing a -1, because remember there's imaginary 1 in front of that y. So I have y, but I divided by a negative, so I need to flip that sign. And I'm going to put the -x divided by the -1 in the front, which will give me a positive x. And the 6 divided by -1 in the back, which will give me a -6. So there's one equation. There's equation 1. My second equation, I need to do the same thing. I'm going to grab a different color real quick. So I have 2x plus 4y is greater than or equal to 12. Let's go ahead and get that in slope-intercept form. So I'm going to subtract the 2x over. So I have 4y is greater than or equal to 12 minus 2x. Isolate y. So divide out 4. I have 1y, that just equals 1, is greater than or equal to, notice I did not divide by a negative or multiply by a negative, so the sign gets to stay. 12 divided by 4 is 3. I'm going to put that in the back. It's a positive 3. -2/4 actually reduces to -1/2 x plus 3. There's equation 2. Okay, so let's go ahead and graph those. I'm going to use the same colors as I did on the equations. That way you know which graph is which. I would really like for you to color code as well. If you have some colored pencils or colored pens, only for the shaded part. So y is less than x minus 6. Well, -6 is my y-intercept. So I'm going to go down to -6, and my slope is 1. So I rise 1, run 1, rise 1, run 1, rise 1, run 1. And since I'm looking at this right here, I notice that it's going to be a dash line because it does not have the equal symbol underneath. So I'm going to dash this line like so. And it's less than, y is less than. So anything below that line will be a solution to that particular equation. That's not, however, the solution to the system. We have to graph the other one and determine that. So let me grab my blue. My y-intercept on my blue equation is 3. And my slope is -1/2, so that means I'm going to go down 1 and right 2. Down 1, right 2. Down 1, right 2, so on and so forth. This symbol, however, means I'm going to have a solid line. So I'm going to go ahead and make my solid line. And it says y is greater than or equal to. So that means anything above the line needs to be shaded. Okay, so now I see blue shading, black shading, and I need to look at, they're coming together over here in this corner, over on this triangular piece. So that's our final answer. So if you'll shade that in really, really dark, that way I know you know where the solution is. Okay? All right, so to finish this up, it's asking if certain coordinate points are in the solution. Some of them you might be able to tell. Some of them you might have to plug in to one of the equations to determine, okay? So we have 6 and 8, 6 comma 8. So if you go over 6 up to 8, 5, 6, 7, 8, like right here, that is not in the final solution set, okay? So we would say no. 0, 2. 0, 2 is right here. No. Negative 1, 0. Negative 1, 0. No. Okay, let's try 3 equations. First one we have is x is less than 4. So if you recall, if you have an x equation, that means it goes through the x-axis and lands vertically. So we have our x less than 4. So we have 4. Going to go through 4, and it has to be a dashed line because it does not have an equal sign. So dashed, and x is less than 4. So anything to the left, because we don't have a top or bottom in this case. So left means less, so we're going to shade over here. All right. And next we have y is greater than or equal to negative 3. So anytime you have a y equation without any x's, then we find negative 3 on the y-axis. It says y is greater than or equal to negative 3. Since it's greater than or equal to, we do have a solid line. And again, we don't have a left or a right to make above or below. We are going to have to say it's going to be above because it's greater than or equal to negative 3. So I'm going to shade there. All right. And lastly, we need to put that one in slope-intercept form. So let's do that. I'm going to subtract the 2x over. So I have negative 2y less than 4 minus 2x. And divide out the negative 2 so that we isolate our y. Whoop, we divided by a negative. Flip that sign. So I have 4 divided by negative 2, which is negative 2. I'm going to stick that on the end because that's my y-intercept. And negative 2 divided by negative 2 is a positive 1. All right, so we have y is greater than x minus 2. So I'm going to find negative 2 down here. My slope is 1, so I rise 1, run 1, rise 1, run 1. And since it does not have the equal symbol, we can only create a dashed line. It is greater than, so anything above will be shaded. I'm going to shade it sideways. All right, so kind of looks kind of crazy here. We have to find where the blue, red, and black all come together. So here is just black and blue, so that's not it. Okay, here is just red and black, so that's not it. This little piece is just red and blue, so that's not it. So anywhere we have red and black and blue will be inside here. We'll have to shade it all the way to the x less than 4, all the way down to the y is greater than or equal to negative 3, and above the y is greater than x minus 2. So that's my final solution. So any of those coordinate points that are in that section, they will be considered a solution.